absolute value inequalities, and we know that the absolute value of some expression u is equal to a means u is equal to a, or u is equal to negative a. And we're going to look at our first theorem related to this. So theorem, I want to go ahead and lock this in place. Okay, theorem says for u less than a is equivalent to negative a less than u less than positive a, and u absolute less than or equal to a is equivalent to negative a less than or equal to u less than or equal to positive a. In other words, u is between negative a and positive a. Let's consider a few examples. And please remember that the examples match the homework problems. So you really want to go ahead and do your homework or make notes for your homework while you're looking at the videos. So 5x absolute less than 25. Using our theorem, this is negative 25 less than 5x less than positive 25. Then dividing everything by 5, because we need to isolate x, we've got negative 5 less than x less than positive 5. So there are three ways to state your answer. You can use the interval notation, which says that simply x is a number located between negative and positive 5. You can use the set builder notation. All x such that x is a number between negative and positive 5. In other words, we just write back what we found out to be the answer earlier. And make sure you put it in the set notation. You can also show this on a number line. That goes from negative infinity to positive infinity. Identify the points negative 5, positive 5, and use parentheses to show that all of the numbers between negative and positive 5 are the solution to this problem. So this is the graphical notation for the answer. If perhaps the problem involves less than or equal to, such as 6x absolute less than or equal to 36, so this would be negative 36 less than or equal to x less than or equal to positive 36. 6x. Divide everything by 6. And this gives us negative 6 is less than or equal to x less than or equal to positive 6. So answers, I'm going to write all three formats. This is negative 6 to positive 6 in brackets this time, because negative or positive and positive 6 are included in the answer. The endpoints are included in the answer. Or you can use the set builder notation to write your answer, or you can use the number line. Pay attention to what MyMATLAB is asking you for the format, but this is simply a number between -6 and +6 on the number line. Example, x minus 2 absolute plus 2 is less than 3. So you want to start by taking away 2 from both sides. This gives absolute value of x minus 2 less than 1. And then we do the setup based on the theorem. So -1 less than x minus 2 less than +1. Notice that to isolate x here, we have to add 2. And we do that to all 3 parts. This gives us -1 plus 2 is +1 less than x less than 3. So x is a number between 1 and 3. In the interval notation, set builder notation, or on the number line. And you make that part in between bold. Notice that 1 and 3 are not included in the answers. It's just the numbers between 1 and 3. 1 and 3. Example, three x minus 2 less than or equal to 4. So the absolute value is already isolated. We would set it up, -4 less than 3x minus 2 less than or equal to +4. Add 2 to each section. We get 2 is less than 3x is less than 6. And then divide everything by 3. I'm sorry, this is -2, isn't it? Divide everything by 3 to get -2/3 is less than or equal to x less than or equal to 2. So x is a number between -2/3 and 2, including -2/3 and 2. Set builder. Or graphically. And this time we use brackets to signify that it's all of the numbers between -2/3 and 2, including -2/3 and +2. Example, -2x minus 1 greater than or equal to -3. So this is actually a less than problem, because if we were to multiply the entire inequality by -1, we get the negative times negative, +2x minus 1, and negative times negative becomes +3, but the inequality flips around. because we're multiplying by a negative number. So now we can go ahead and do our setup. This is -3 less than or equal to 2x minus 1 less than or equal to +3. Add 1, add 1, add 1. We get -2 is less than 2x less than or equal to 4. And then divide everything by 2 to give -1 less than or equal to x less than or equal to 2. So x is a number between -1 and +2, including, so brackets, including -1 and +2. Set builder notation. And graphical notation. -1, +2 on the number line. No. All right, let's do one more example for less than inequalities. So 1 minus 4x absolute value minus 7 less than -2. So 1 minus 4x, we're going to go ahead and add 7 to both sides. To give less than 5. And then we use the theorem to set up our inequality, less than 1 minus 4x less than +5. Next step in the process is to take away 1 to give -6 is less than -4x is less than +4. Now we want to go ahead and divide by -4. And that kind of flips the inequality around, because we have x and -1. So now we're seeing what's happening in here is that the larger number is at the front and the smaller number is at the back. So we want to rewrite this inequality with less than by putting -1 is less than x is less than 3/2. This to show that x is a number between -1 and +3/2. Or in the set builder notation, all x such that x is between -1 and +3/2. Or we can use the graphical notation to say -1 and +3/2. Now let us examine the theorem related to greater than problems. So theorem says that u absolute greater than a is equivalent to u less than -a or u greater than +a. And absolute value u greater than a is equivalent to u less than or equal to -a or u greater than or equal to +8. So examples: 2x minus 4 absolute greater than or equal to 3. So we use our handy theorem and we say that 2x minus 4 is less than or equal to -3 or 2x minus 4 is greater than or equal to positive 3. Go through the process of solving here. We get 2x is less than or equal to 1. X is less than or equal to 1/2. Add 4. We get 2x is greater than or equal to 7. So x is greater than or equal to 7 over 2. Well, so it's really important here how to write the answer for this. So what you probably want to do is look at how this answer is on a number line, negative infinity to positive infinity. This is saying all of the numbers that are less than half, so everything to the left of half, including half, and all of the numbers that are greater than 7 over 2, including 7 over 2, bracketed. And when you write the answer for this, you want to state it, the interval notation, from negative infinity up to half. Now remember, infinity or negative infinity is always parenthesis, never a bracket, forming a union with 7 over 2, bracket, to positive infinity. Let's make that bracket a little better so it's very clear. Remember, if the inequality has an equal sign, we use a bracket. Or you can use the set builder notation to write all x such that x is less than half or x is greater than 7, or greater than or equal to 7 over 2. Example, 3 minus 2x greater than 11. So remember our setup here, this is 3 minus 2x less than negative 11, or 3 minus 2x greater than positive 11. So I would go ahead, take away 3 here. I have negative 2x is less than negative 14, and divide by negative 2 to give x is greater than 7. Notice the flip in the inequality because I divided by a negative number. And following the process here, I would take away 3 from both sides. I have negative 2x is greater than 8. So dividing by negative 2 gives x is less than negative 4. Okay, notice again that the inequality was flipped because I divided by a negative number. So I'm going to recommend that we draw a number line here first and see what they're talking about. They're saying that x is all of the values that are less than negative 4, so to the left of negative 4, and all of the values to the right of positive 7, greater than 7. So remember, when you write the solution for this, to start from left to right, from negative infinity to negative 4. This time we're using parentheses on both, and then from 7 to positive infinity, forming that union with 7 to positive infinity. Um, so I just wanted to mention two quick examples in passing. One is, and this is FYI information, if I'm given 4x plus 15 less than negative 2, now we know that absolute values are always positive or 0. So in this case, there is no way that it can be less than or equal a negative number. Okay? So there is no way they can be less than or equal to or less than or equal to a negative number. So in this case, we have absolutely no solution to this problem. No solution, since that absolute value cannot be less than or a negative number. And if we have a case where, say, let's see if I can come up with a good example here. This is 2x minus 9 is greater than or equal to negative 8. Now, since the absolute value is positive or 0, then it will always be greater than a negative number. Since absolute value is positive or 0, this inequality is saying greater than negative 8. So it will always be greater than a negative number. In other words, the solution here is all real numbers from negative to positive infinity, or in the set notation, x all real numbers.